Hello, everyone. Thank you for joining us today. We have two talks lined up for you in this 50-minute session. My name is Lee Saunders, and I'll be kicking us off with a demonstration on how you can set up connectivity from Power BI to data sitting on the HPCC platform, and talking you through how to set up end-to-end automation. After that, I'll pass over to Jack Del Vecchio, who will be talking us through interfacing MongoDB into ECL. Jack is a bachelor's student studying computer engineering at the Miami of Ohio University. Jack joined the intern program to add MongoDB to a growing list of new embedded languages and data stores that can be leveraged by HPCC devs for their big data projects. Hopefully, we'll have plenty of people listening who will benefit from one or both of these demonstrations. Please use the Q&A section throughout both the talks. Jack and I will be available alongside Cleo Johnson, our moderator, and we'll have some other tech Jedis at the ready. So hopefully we'll be able to cover off all of your questions today. Jack and I will be using slides rather than live demonstrations, and we'll make these available to you to support your implementations. If you need to reach out to us, be it for guidance when implementing, or if you're watching this at a later date and you have some questions, please don't hesitate to get in touch. Our details are provided here on the slides. So I'll kick things off. Once again, my name is Lee Saunders, and I'm a LexisNexis Risk Solutions employee working in the Data Insight team. I'm based in Cardiff in the UK, and I've worked for LexisNexis Risk Solutions for over 4 years. Over that time, I've witnessed more and more teams using Power BI to visualize performance or monitor their processes. And with automation key to many operations today, I'm hoping the solution in this presentation will be a game changer to those using HPCC and Power BI and looking for a solution to automate their data updates. As a bit of background, some time ago, my teammate Cleo Johnson and I, we began migrating all of our reporting over to Power BI. As you'd expect from a data insight team, there were plenty of reports, and especially on the US side. Manually exporting data and refreshing these was unsustainable. So we set out to find a solution to automate this process. At that time, we had two potential solutions on the table. First solution, and some of you may have this in place in some shape or form, was using CSV files. This would involve setting up ECL code to output and display data to Thor, and a DOPS process to migrate the files from the Linux landing zone over onto a Windows location. The second, and the focus of the demonstration today, was setting up a web connection in Power BI via a REST URL JSON output. Both of these solutions, they have their pros and the odd con, and these days we use them in combination depending on the report we're producing. As I've mentioned, the focus today will be on the REST URL automation. But if you are interested in finding out more on how we set up the automation using CSVs, please let us know in the chat, and we can arrange to run through that in more detail with you. So let's get things started. Today, we'll cover outputting data and publishing queries. And then we'll look at retrieving the REST URL from the published query in ESP. And then we'll look at using the URL to connect to the data within Power BI. And then finally, we'll touch on Power BI gateways and the auto refresh. So step one, outputting your data. I've used this very simple data set with an output statement here, placing the data on Thor as a Thor file. For full automation, this process could be triggered at the end of a build, as something scheduled with DOPS or via a cron. This is a very simple example, but it would be at this stage, I would use HPCC to do all the heavy lifting, outputting a summarized metadata file that I can then use in Power BI, maybe tweaking it in Power Query, but essentially this would be the end data that we want to load into Power BI. I've added a little best practice note here just to call out. I've not compressed this file as it's just a small test data set. In all production instances, I would add in the compressed parameter. Okay, once that work unit is complete and the data is now on Thor, we can create some ECL code to retrieve and output all data. These two things are quite key to this process. Firstly, we don't want to have a complex query running here. We just want a very simple file retrieval. Later, when we connect in Power BI and run refreshes, this will make things more efficient and avoid any timeouts. Secondly, we need to make sure we output all the data in this work unit. This may mean altering the output limit if your file size is over the 10 megabyte default. If you have very, very large files, then this process might not be suitable. Again, if you joined a little late and missed the introduction, we do have an alternative CSV automation solution. Please let us know in the chat if you're dealing with larger files. The CSV process may be more suited, and we'll be happy to guide you on that one. Note, I've the limit amendment, although we don't need it here, I put it in there for your reference. I've run this on HTHOR as we don't require any processing power, as we're just retrieving a file. This will output the data in a work unit. So over to ECL Watch then for the next steps. So next, locate your work unit. Here's this one I've run. So once it has run, we can now look to publish. That's all we need to do here is click on the publish button and enter a name for the publish query. There is no delete button on ESP for these queries, so do take care. It's worth keeping a consistent prefix, report name, file name, naming convention, especially if you plan on publishing lots of queries. For example, I might name this one Data Insight, HPCC Testing, sample file. Once that's published, we can log into ESP by amending the portal after the IP address and view the query. This will also be in HTHOR, as that's where we've run the query from. So yeah, navigate and highlight the query from this branch will present these options. There are a few options here. You can output the results into a table. That can be useful to link data into Excel. There are also XML options, but we're going to use the output JSON. Next, this second drop down is defaulted to form post, but we want to select REST URL and then submit. This will run another work unit in HTHOR. The data retrieved will be converted into a JSON script and shown in a new tab. If you make any changes to the file on HTHOR, for instance, if the publish query in each day, this will be reflected in the JSON output each refresh. So here it is. Once it's finished, you'll be presented with this new browser tab. It contains the URL and the data in the JSON format. You can now copy this URL and use it in your web connection within Power BI. Here we go. So over to Power BI desktop. We can now click the Get Data option, select Web, and then paste the URL into the text box that loads. At this stage, when you click OK, you'll be asked for your credentials. I use a service account with a password that doesn't expire. I would highly recommend this setup if you want to maintain full automation. Without this, you will have to update connections each password change. So then click Save, and hey presto, the data is now available in Power BI. If you have a lot of data, just be aware that it can take a little time to process and for the data to load. Some other things to note at this stage: each table with this connection will kick off a work unit on refresh. So any duplication of this table will cause duplicate work units. If you use the reference option, this will avoid unnecessary jobs on HStore, but be aware any changes in this table will reflect in the reference tables. We've just connected one data set here so far, but if you may need to connect to more than one data set in HPCC. You can add multiple outputs to your published query, and these can be handled in Power BI. The one advantage being the reduced amount of queries you need to publish and maintain on ESP. If this is a requirement, follow the same steps we've just gone through. However, you will notice when the data loads to Power Query, each output is in a separate column, just like this. All we need to do is a little bit of work, just let Power BI know how we want to handle these. Here's an example where I'm using it for some demo data. So note the name of the outputs here are reflected in the column title, so it's worth adding that into your ECL code, just so you can easily keep track which one's which. You will need to retrieve the data for each output separately. I'll call out here from my experience using the multiple output process, you're unable to reference from this view. Well, you can, but separate work units will be run for each data set you extract, unfortunately. To get the demo names data in this example, we can click on the double arrows and select expand to new rows. And once that's done, we can click on the double arrows again. And this will pop up with a list of all the fields that are available to that data set. You will also see this additional tick box, which I've highlighted in blue. Use original column names as prefix. Unticking this box will remove the long prefix for column names. Once you're happy, click OK, and you'll see all your expected rows and columns. A couple of things to add. The other dataset column here will need to be deleted. You can do this straight away or after you've extracted all the data. Also, this will mean all the work units that run to update your report will be the same code. And if you've named the work unit, that will be the same as well. So bear that in mind. One last efficiency tip. If you have a few different data sets that need to be connected, and one of these is a non-updating data set, maybe some old historical data that you want to use in the report, but it will never update, never change. You can set up a connection and remove it from the report refresh. This will reduce any unnecessary HPCC activity. So that's the connection set up. We'll now look at completing the automation. Power BI comes with an auto refresh tool that allows you to schedule automatic refreshes of your background data set. Before I show you how that's done, a key part of this process is the gateway. There are two types of gateway, an on-premises gateway and a personal gateway. The personal one will require your computer to be on and running for the refresh to be successful, which is not ideal if you plan on running your reports out of hours. I would recommend getting an on-premises gateway set up. This will involve or require the FIDO team for you LNRS employees listening, or your equivalent IT team. They'll set up a gateway using your cluster's IP address and your service account details. So assuming that you have that all in place and ready to go, here's how you set up the auto refresh. First things first, we need to make sure the report is saved and published. I've published this into into my workspace. Now we can go over to the Power BI portal using the app.powerbi URL. Browse to the workspace where you published your report. You can do that using this little icon here in the left options pane. So find the report. This one here, and in the data set, that's the red one here, using the ellipsis, go to settings. So the following view will be presented, hopefully. From here, you can map the data set to the gateway, and you can set up your auto refresh. So firstly, expand the gateway connection, giving you these options. Then use the Maps to drop down to select the name of the gateway that's set up on the cluster. Once you click apply, this will allow you to set up a refresh schedule. So here, toggle on the scheduled refresh option and amend the parameters to suit your report needs. You can add multiple refresh times per refresh frequency by using the add another time option. You can also customize your failure notifications. By default, it will mail any issues to you, but you can tick the other box and create a customized distribution. Once you're happy, click apply, and full automation is now set up. That's it for me. Thank you all for taking the time to listen today. I hope that was useful. Please feel free to reach out to me if you need any support, or if you are interested in finding out some more details on the CSV automation. Thanks again. I'll now hand over to Jack.
Thank you, Lee. Hello, everyone. My name is Jack Del Vecchio, and I will be talking about interfacing MongoDB into ECL. Over the summer, I had the opportunity to intern with HPCC Systems, and this was the project that I worked on. So my motivations for this project were I've had some experience working with MongoDB in the past. I found that it was easy to learn, and they offered a lot of functions that made working with the data very easy. Another motivation that I had was I've always been interested in getting involved with the open source community, but I found, it's a little difficult to get into. And so the internship with HPCC Systems was the perfect opportunity for me. because I had the support of a mentor who was a senior developer on the team, and it just made this whole opportunity a lot better. So my last motivation for this project was I'm always interested in high performance computing because I just enjoy seeing computers push to their limits and finding out the capabilities of them. So some goals for this project were to insert ECL records and return MongoDB documents as ECL datasets, updating and deleting documents from a MongoDB database, chaining multiple operations together using an aggregation pipeline, which is a function of MongoDB, creating test cases and examples of the plugin being used for anyone looking to use the plugin or embed it in their code. And the final goal was for creating documentation that was extensive enough, it would provide some help to anyone trying to maintain or extend the plugin and just give a general idea of how the plugin works. Some challenges that I faced during the project were, for example, learning ECL and HPCC systems. The platform for me was brand new, so I had very little experience with it, but the training and all the examples that are provided by the ECL community helped a lot. It was also difficult for me to get everything integrated with VS Code, but there's a great extension for the ECL language that allows you to work seamlessly from VS Code, and you can run work units and see the output of that right in VS Code. So that was nice. I was also able to get GDB running so that I could debug from the remote VM that I was developing in. And that was a challenge at first, but it was really a necessity because it made the development process much easier. And while I had experience with MongoDB in the past, I have used the JavaScript driver as opposed to the C++ driver, so this was my first time using it. So there was a few hiccups there. The final or another challenge that I had was I ran into some data limitations where because of the free tier cluster that I was using for development, I exceeded my data bandwidth, so I got throttled there for a little bit. So that was something that I had to learn on the fly as well. And then the final challenge was MongoDB extended JSON. So here's an example of what some of the formats of it look like. Essentially, it is just a way to encode additional data types into normal JSON. But some of these data types aren't necessarily supported in ECL, so they had to be deserialized. And I'll talk about that more in some later slides. Here's an example of what a document looks like from the MongoDB Atlas, which is their web UI. You can see all the different data types there. They have date data types, there's arrays, objects, all kinds of stuff there. So this is how the ECL data types get translated to MongoDB eJSON. It's pretty straightforward for the Boolean and real data types. Those are pretty one-to-one. The first caveat is that MongoDB does not support unsigned integers. So the signed integers get converted to 64-bit signed integers. And then all of the different types of string data types that ECL supports, those all just get converted to UTF-8. And then finally, for MongoDB to ECL, the date data type just gets converted to a string because there's no native date data type in ECL, unfortunately. So in order to query MongoDB, we need to provide either a document or an aggregation pipeline, which is essentially an array of documents. Some functions can take multiple documents as filters or other kinds of things, operations. So the plugin handles that as well. And then function parameters can be placed in the embedded script with the prefix $. So here's an example of embedding MongoDB into ECL code. This block of code would be placed anywhere in your ECL code after the import MongoDB statement. Once you import it, you can see here that we're using a find function. So since the find function returns some data, we declare a output or a return type. In this case, we're using a data set with just a standard layout rec. If you're not familiar with how data sets work in ECL, feel free to drop a question in the Q&A. There's plenty of people that will be happy to help you there. Then once we get to the embed statement, you can see that you have to declare what plugin you're embedding, and then you have to pass in some parameters for connecting to the cluster. So in this case, you need to provide a username, password, the server address, and the database and collection that you want to run your operation on. And then you just call the find function inside the embedded script and call it in the output, and it will run for you. Inserting documents. So here's two examples of inserting documents. In the first example, we use the insert one function. The insert one function gets called automatically. You don't really need to declare insert one, you just say insert. And because you're passing in some scalar values, the plugin knows that you're inserting one document at a time. And since this doesn't have any output, we don't need to return or declare a return type. In this case, you can see that the parameters name and num get passed into the embedded script with $signs in front of them. The plugin will, when it's building the document, replace those values in the script with their data types preserved. In the second case, it's pretty similar, except we're importing a data set. So each record in the data set will get inserted. MongoDB uses insert many to insert them all at one time. And this is much more efficient if you're inserting multiple documents or just many documents. And then this does return some output, as there is some status that MongoDB returns. So to capture that output, there is a template type for the MongoDB plugin. So you don't have to actually know the field names. And then we just call those functions at the end. And for the output, we can name it. So here are some other functions. They're all very similar. So the find one and find documents. In this case, we do want to declare that we just want to return one document. If we want to declare find one if we just want to return one document. But if we don't declare that, then it'll just find all the documents that match the filter. Again, you can see the parameters are just placed in the embedded script. All these functions are very similar. They just take documents as their arguments. So it's very straightforward. One thing to note is you can pick which fields get returned by declaring that layout record in the dataset. But there's also another way to do this on the MongoDB side. You can pass in an additional document called a projection as an additional argument, but you don't need to do that. So this is an example of a result record that you would see from the ECL watch. In this example, the transactions field is what an array of objects would look like. These can grow pretty big, so I limited it to 5 documents just for the test. So keep that in mind. So updating and deleting documents, very similar. They both have a update one, delete many for each kind of query that you would want to run. So for the update function, you'd pass in a filter as the first argument and the operation that you want to run for the second argument. So in this case, any document that has a name that matches John Doe, we're going to increase that salary by the number that we pass into the function. And for the delete, we just pass in a filter, and depending on if we use delete or delete many, one or many documents will get deleted. And both of these functions have some output that returns the status of the query. So to capture that output, there are 2 template types provided by the plugin, so you don't actually have to know the field names of those status results. So aggregation pipelines are another function from MongoDB. They're very powerful. you can chain multiple operations together in one statement, which is very nice. So in this example, we have a group operation that we're running. It will find all of the documents that have a field with property type and count how many property types there are. And then it will sort those results by the number of counts. And then for the aggregate function, we want to capture the group fields that we declared. So ID and count are the record for the data set. And then we just call that function in the output and name it. So another function by MongoDB that has some different uses. This is the run command function. And it's slightly different than the other ones in that it runs at the database level instead of the collection level, which is slightly different. So it's a tier up, but it allows you to do some more things. So in this example, we are removing a document from the collection name that we specify, and it matches a query with the name Ann Smith. There's a lot of other functions that you can do, and the output to those functions is specific to what you're running. If you want to find more information about the run command function, the manual is linked in the README on the MongoDB plugin GitHub. For creating indexes, this can be very helpful because it allows you to only query certain fields. This can help if you have a very large database with many records, but you only want to search a subset of those records. You can use the create index function to create an index on those fields that you want to search more frequently. And to also make it more efficient, you can sort that index. And to sort it, you just I used a ascending variable, and then you can pass in, whatever value you want when you call the function. So finally, the documentation for the plugin was created using Deoxygen. The entirety of the MongoDB C++ driver was also in Deoxygen, so I was very familiar with it. I found it very helpful, so I wanted to create something similar for my plugin, just because there's a lot to document, and having it auto-generated for you really makes it a lot more simpler. The README on the GitHub is the main page for the documentation. So if you don't feel like generating it, you can get most of the information from the README. And yeah, that's all I got. So thank you to everyone who stuck around. I hope you were able to gain something from, one or both presentations. If you have any questions, please feel free to drop them in the Q&A section. Lee and I will be sticking around for a little bit to answer any that you might have. And if you're watching this in the future, please feel free to reach out to me or Lee. Our contact information is in the slide. And yeah, that's all I got. Thank you.